Britain has a long tradition of timber framing. These buildings from the 15th and 16th centuries are made from a framework of beams and columns, mostly oak, with an infill of wattle and daub covered with limewash. Painting the frames black was a Victorian fashion. Prior to this, the oak would have weathered to a pale silver colour. By the 17th century, timber framing had reached its height of sophistication, but it gradually gave way to brick construction because of the risk of fire and the rising cost of timber. Modern timber framing has its origins in North America and Scandinavia and bears little resemblance to its medieval form. Indeed, many new timber frame houses are virtually indistinguishable from their brick and block counterparts. They're made from a series of load-bearing panels, usually storey height, which support the loads from the upper floors and roof. In this country, the frame is normally hidden by brick cladding. Although there are earlier examples of this method, it wasn't widely adopted until the late 1950s. In 1957, the Canada Trend House was promoted at the Ideal Home exhibition as a modern, cost-effective, energy-efficient alternative to brick and block houses. At a time when there was a huge demand for housing but a shortage of skilled labour, it became a popular form of construction for both public and private sector house builders. They were attracted by the apparent benefits of prefabrication and the speed of construction. During the 1960s and 1970s, hundreds of companies developed their own timber frame systems, and its market share grew rapidly. By the beginning of the 1980s, some 20% of new houses were timber framed, but a burst of largely unfounded adverse publicity reduced this percentage considerably during the middle of the decade. In fact, a number of recent reports have concluded that timber frame is no less reliable in terms of defects than traditional brick and block cavity walls. In timber frame housing, good quality doesn't just start on site, it starts in the factory. The load-bearing structure is prefabricated in a controlled environment and delivered to site ready for immediate assembly. The process begins with the architect's drawings.
From receipt of an order for a timber frame development, whether it be a single house or a multi-flatted development, we receive a full set of drawings from the architect. That's the architect's original design plans. We then convert those into timber frame terms. In other words, we produce timber frame drawings, which include sole plate layouts, which are setting out drawings, panel layouts, floor joist layouts, roof truss layouts, sections through the building. We also provide a full set of construction details, a full set of structural calculations. That package of information assists the design team, the client, apply for his building regulations approvals, and we send those to the client for them to apply.
A typical timber frame wall panel is formed in preservative-treated timber and comprises a series of timber studs nailed to top and bottom timber plates. The outside of the studding is covered with plywood or other suitable sheet material. In practice, even a modest housing estate will contain a range of different panels. The computer-aided design process produces not only the site assembly drawings, but also the cutting lists and production information ready for the factory floor. In a two-storey house, the timbers are normally 90 mm deep and 38 mm wide. Increasing the depth to, say, 140 mm is an option which will allow for much higher levels of thermal insulation. The framing timbers are generally softwoods from Scandinavia, where the cold climate and short growing season produces a relatively dense timber. Prior to arriving in the factory, the timber is stress graded, either by machine or by eye, to ensure it's of adequate strength. The timbers are often planed on all faces and edges to make them easier to handle. panel isn't rigid and can easily be deformed. This is known as racking and is most likely to be caused by wind loads. To make the panel rigid, it's covered by a sheet material such as ply or strand board. This sheathing layer should be nailed to the studs and the plates. Where windows and doors occur, shorter timbers, called cripple studs, support the timber lintel over the opening. A vapour-permeable but waterproof layer is stapled to the outer face of the frame. This layer, known as breather paper, initially shields the panel from rain during construction and protects the finished structure from any water finding its way across the cavity. Because the breather paper is vapour permeable, any trapped vapour within the panel can escape. This helps combat condensation. To finish the panel, a temporary hem is formed. On site, this will provide an overlap with the panel below. The position of the studs are marked with tape so that the bricklayers can position their wall ties in the correct place when building the cladding.
The typical average developer's house, say a 3-bedroom semi-detached house or even a detached house, would take something in the order of 2 to 3 days to erect. That would be utilising the crane erect method of construction. And that would be for ourselves to erect the external wall panels, the internal wall panels, the floor structure and decking, the first floor wall panels, internal wall panels, and the complete roof structure in a 2 to 3 day period. It would then be ready, that building, that structure of the building would be then ready for the developer on site to commence roof tiling. So really very close on to something in the order of a week. That developer would have a dry envelope ready for his internal trades to be working inside.
Close coordination between the manufacturer and builder helps to ensure that deliveries occur as and when required. This prevents unnecessary storage and exposure, and at the same time provides a steady stream of work for the site operatives. On compact sites, this also prevents the need for multiple handling. On-site, timber frame, like any other prefabricated system, is less forgiving than brick and block construction. Depending on the specific design, an accurately cast foundation or floor slab is therefore essential. The high water table on this site precluded traditional foundations. Driven precast piles were used instead. Precast beams span from pile cap to pile cap and carry the timber frame and the brick cladding. If the ground is unsuitable for traditional foundations, it's not likely to be suitable for a ground-bearing slab. Here, a series of pre-stressed beams with an infill of aerated blocks form a suspended floor, quite independent of the ground below.
The most widely used method of construction, a method of timber frame construction that's used in the construction industry, is called platform frame. Platform frame is effectively where timber frame wall panels sit on top of the floor construction, giving it the name platform frame. That is by far the most common method of timber frame used in the UK. It's also what we call an open timber frame wall panel, i.e. the wall panels are prefabricated in lengths suitable for crane erection or hand erect, lengths of around 3.5 metres, with factory fixed sheathing on the outside, but in between the studs, insulation and plasterboard linings and services are actually fixed on site, hence the term open frame. Timber frames are always erected by timber frame specialist erection crews. We would regard that as a trade itself. Timber frame erecting is a specialist trade. The gangs work in teams numbering anywhere between 3 and 5, and those teams can then be multiplied depending on the size of the development.
Once the substructure is complete, erection of the frame can begin. The first stage is to lay the DPC and fix the sole plate. It can be secured by shot firing into the blockwork or by angle brackets. Angle brackets avoid the need to puncture the DPC. However, there's no hard evidence to prove that nailing through the DPC leads to damp penetration. In practice, a polythene DPC forms a tight collar around the nail. The ground floor panels are nailed to the sole plate and to each other. As long as the sole plate has been accurately set, level and square, the panels will be a good fit. Minor discrepancies in the substructure can usually be overcome when the sole plate is fixed. The sole plate here has been doubled up to suit the nature of the floor finish, which incorporates a thick layer of insulation. Internal load-bearing partitions, which help carry the first floor joists, are also made from studding. These will eventually be covered with plasterboard both sides, with horizontal noggings to provide stiffness. In some cases, these walls will contain raking braces because they contribute to the rigidity of the whole frame. Window frames can be installed on site or even in the factory. Systems vary, but most are just nailed to the wall panels. Once the ground floor panels are in position, the breather paper hems will be lapped at the corners and lapped over the sole plate to protect the timbers from rain.
There are many advantages for timber frame construction. The main one being speed of construction. It's quite typical for a development or a project constructed in timber frame. It should find at least a saving of 30%. You are using also sustainable materials. It's a much lighter form of construction, so there are savings in terms of the foundation design, particularly if you're building off poor ground conditions, perhaps where the ground needs to be piled and so forth. Other significant advantages include the fact that we will achieve accurate completion dates, mainly because we're not reliant on any weather conditions. If it's raining or snowing or sub-zero temperatures, timber frame developments, timber frame buildings will continue to be constructed. The bricklaying trade and those wet trades, particularly bricklaying, are taken out of the critical path of the building programme itself. So all of a sudden you have building projects that aren't reliant on the brickwork trades.
The construction of the first floor is very similar to that used in more traditional houses. What differs is the edge detailing. A head binder is nailed on top of the panels, followed by a header joist and the joists themselves. The head binder is a long strip of timber which helps align the panels. The header joist supports the upper panel and protects the floor void from fire. Without it, a fire in the cavity could quickly spread in between the joists. The joists themselves also help to support the upper panel. Where joists run parallel to the panel, the detailing is slightly different. An additional header joist is required to support the upper panel. It can be offset 25mm or so to provide a fixing for the plasterboard ceiling. As in traditional construction, there are several suitable floor coverings. On this site, it's tongued and grooved, moisture-resistant chipboard. In platform construction, the floor covering runs right to the edge of the frame. This inevitably means that the upper wall panels sit on the floor finish. The building regulations limit the position of notches and holes in joists. These copper pipes run through the centre or neutral axis to minimise weakening. The felt stops annoying knocks and rattles in use. Pipes and cables can also be accommodated in a service zone formed by notching out the joist. Here, the wall panel is supported by ply packers rather than the floor covering. This makes it easier to remove or renew the flooring. A removable cover gives easy access to pipes and cables. This may increase capital costs slightly, but it will certainly save money in the long run. The completed floor covering provides the platform for the upper storey wall panels. In two-storey housing, these can be lifted by hand. Cranes are usually required for 3 storeys and above. Once the panels are nailed in position, the construction of the roof can begin. In some timber frame systems, a head binder is fixed over the panels. In systems without a head binder, the trusses should always be positioned directly over the load-bearing studs in the panel below. The trussed rafters are skew-nailed to the head binder or fixed with special clips. In a traditional house, the roof cannot be erected until the cavity wall is complete. But in timber framing, the brickwork is only a cladding and its completion is not critical. Once the panels are in position, the roof structure can be assembled on the ground and lifted into place or built in situ. When the roof's been covered and the windows fitted, a dry environment is created ready for the second fixing. In other words, ready for the finishing trades. The wall insulation has to be covered with a vapour check to ensure there's no risk of interstitial condensation. This could theoretically occur during cold spells if moist air comes into contact with the inner face of the sheathing. The vapour check must be carefully cut and sealed around the sockets, switches and pipes which pass through the membrane. Self-finished plasterboard with taped joints usually provides the finished wall surface. A sound-deadening quilt can be added to internal partitions, for example where a kitchen is next to a study or bedroom. In this country, the cladding is usually brickwork, but timber weatherboarding is a practical alternative. One option is shiplap boards nailed to vertical battens. Another option is to counterbatten the sheathing layer and fix staggered vertical boarding. It's even possible to fix a paper-backed mesh to vertical battens and render it. All these claddings are supported entirely by the timber frame, but a brick cladding, because of its weight, requires a foundation. A cavity between the brick and the timber helps keep the frame dry. However, a half-brick wall is not freestanding and must be tied to the frame. The ties must be flexible to accommodate minor differential movement of timber and brick. Once erected, the timber frame will shrink in height by 10 mil or so, as its moisture content stabilises. The brickwork is supported by a steel lintel over openings. It should not be secured rigidly to the frame. Clips fixed with a small gap allow for differential movement. Most lintels require separate cavity trays to direct any water towards the outer leaf of brick, where it can escape through weep holes. Where timber-framed houses have cavity walls, fire barriers are required to limit the spread of fire. For a detached house in England and Wales, they're required along the eaves and verge. In Scotland and Northern Ireland, the regulations are more onerous. Additional cavity barriers are required around openings, between suspended floors, and at specified centres vertically. In semi-detached houses and terraces, the need for party walls makes the detailing more complex. A party wall must provide 1 hour fire resistance and good resistance to the passage of airborne sound. The party walls are normally framed from 2 panels. A combination of board sheathing and diagonal bracing prevents racking. A metal strap helps to maintain the integrity of the wall in the event of a fire on one side. It also helps distribute wind loads along the terrace. To achieve the necessary fire protection, the cavity at either end of the party wall must be filled with a metal reinforced quilt. Additional cavity barriers are required either side. The reinforced quilt must run the full height of the party wall and across its top to the ridge. To improve sound insulation, the panels can be filled with a sound-deadening quilt. 2 layers of plasterboard with staggered joints complete the requirements for fire protection and further reduce the passage of airborne sound. Alternatively, the acoustic quilt can be placed in the cavity itself. Some manufacturers provide alternative construction details. These composite floor joists, for example, offer a number of advantages. They're capable of long spans, they're light and easy to handle, and their lattice design eliminates the need to drill and notch for surfaces. This panel, produced by Prestoplan, is a fairly recent development. The plasterboard lining includes an integral vapour check. This means that the separate polythene membrane shown here is not required. A waterproof, vapour-permeable sheathing precludes the need for a separate breather paper, and insulation is made from recycled paper blown into place. This film has explained low-rise timber framing. In some countries, timber frame is used for much higher buildings. A recent research project carried out by the Building Research Establishment and the timber industry has explored the limits of timber framing, and multi-storey commercial and residential buildings may soon be commonplace in the UK.